Welcome to the fourth webinar in our series on belt drives and matching accessories. In this session, we focus on what we call our metal products. We will walk you through the design of V-groove pulleys and taper bushings, highlight their advantages and show how they can be mounted efficiently and reliably in drive systems. We will start by looking at what a V-groove pulley is and which design types exist. Then we will cover materials and standardized designations. Afterwards, we turn to taper bushings, their function, design, and mounting. We will also discuss the practical advantages they offer. Finally, you will get a brief preview of our next webinar series. V-grooved pulleys, also known as V-belt pulleys, are key components in a belt drive. They transmit torque from one shaft to another using a V-belt. The term V-groove pulley refers to the characteristic V-shaped grooves that create a friction lock connection with the belt. In Germany, V-groove pulleys are standardized according to DIN 22171 to ensure consistent quality and compatibility. V-groove pulleys are available in various materials depending on the application. Cast iron is used when high strength and good vibration damping are required. Aluminum is well suited for high speeds or when low inertia is important. For specific applications, bimetal versions are available that combine an aluminum pulley body with a cast iron hub. For lighter-duty use cases, plastic pulleys are also an option. The hub is the central section of the pulley. It sits on the shaft and ensures reliable torque transmission. Solid pulleys are compact and common for small, single-groove pulleys. Web-type pulleys feature a continuous disc, similar to an automotive steel rim, connecting the hub and the groove profile. Arm-type pulleys use individual spokes, reducing weight and making them suitable for larger diameters. The hub of a V-groove pulley can be designed in several ways. The simplest version is a pilot bore that can be machined later to the required size. For immediate mounting, finished bores are available either with an H7 tolerance or with an integrated keyway. The keyway is a traditional method of transferring torque from the shaft to the pulley. It is cost-effective but requires more installation space and offers lower run-out accuracy compared to a taper bushing. In addition, pulleys can be supplied with a bore designed for use with a taper bushing. Pulley designations provide quick information on the profile type, number of grooves and bore diameter, making it easy to select the correct component. A typical single-grooved example is SPA 125. SPA indicates the belt profile, in this case, a narrow V-belt. 100 is the outer diameter in millimeters, and 25 is the bore diameter. Multi-groove pulleys with 2 or more grooves are also available. They transmit power through multiple belts, increase power capacity, and improve load distribution. Typical examples include a 2-groove version like SPA 2125 for medium power ranges, or a 3-groove version like SPB 3160/30 for high-power drives. Taper bushings, also known as taper lock bushings, secure V-groove pulleys firmly on the shaft. They consist of a conical metal sleeve with a slit along its length. This slit allows the bushing to contract around the shaft when the screws are tightened. Once the bushing is inserted into the pulley's tapered seat and the screws are tightened, it forms a rigid, backlash-free connection between shaft and pulley. Thanks to the taper principle, no keyway is required. Taper bushings offer numerous advantages compared to traditional keyway connections. They require very little axial installation space, provide precise centering and excellent run-out characteristics, and offer axial security even for small torque values. Because they are widely standardized and readily available, they can be sourced quickly in many sizes. Overall, taper bushings offer a cost-effective, versatile, and reusable mounting solution. Taper bushing designations typically consist of 3 parts: the type series, the taper size, and the bore diameter. For example, TB 161025. The 16 identifies the bushing series, 10 the taper size within that series, and 25 the bore diameter in millimeters. This standardized system makes it easy to match the correct bushing to the correct pulley and combine stocked components efficiently. A particularly practical feature of the taper bushing is its 3 holes. 2 are used for mounting and tightening, while the third is dedicated exclusively to removal. This allows the bushing to be released without damage and without special tools. During mounting, the bushing is positioned in the pulley's tapered seat and clamped axially using the mounting screws. For removal, the screws are placed into the extraction hole, allowing the bushing to disengage from the taper without harming the components. V-grooved pulleys and taper bushings may be small components, but they are essential to the efficiency and service life of a belt drive. A system will only run smoothly, with low vibration and minimal wear, when belt, pulley, and bushing are perfectly matched. Standardized modular components also simplify spare parts management, reduce installation time, and support cost-efficient operation. This concludes our webinar series on belt drives. If you joined us for the first time with this video, feel free to explore the other sessions in the playlist. Next, we will turn our attention to cylindrical roller bearings. We look forward to having you with us again. Thank you for your attention.